Hey guys, this is K2's Retro Workshop. Today we're going to be dealing with this 386 SX40 motherboard. This motherboard works perfectly fine. This isn't a repair video or anything like that. What I have on this board though is the original manual for it. And as you can see, it says that it's a 386 SX486 SLC mainboard. So what I've gone ahead and done is I've picked up a 486 SLC processor. And I'm going to desolder this guy, clean it up, throw the 486 in there, and we'll see if I can turn this into a 486 motherboard. Alright, here we've got our motherboard. It's on the PCB preheater that I've got here. You'll hear a clicking going on, and it's the thermal camera. I've got one of the USB-C Seek cameras on my phone here. Record that video. So what we're going to do here is we're going to heat the pins up and then check when our chip is loose, and hopefully it'll come off cleanly without any problems here. Let our hot air gun warm up. And it is up to temp. Yep. Here we go. Kapton tape does not like that. And there we go. Our 386 has been removed. Now what I'll do is I will clean up and we'll get the 486 down on here. So what we're going to do now is we're going to take our solder wick here and we're just going to clean these pads up a little bit. The processor came off cleanly and everything, so there's not much residue or anything we have to worry about. I just want to make sure we're starting with fresh pads with the new processor. There is one potential issue that I see here. The 486 DLC has a pad underneath it for keeping the processor cool, and I don't see anything like that on here. So I may have to make a little thermal pad or something work for that. We'll have to see how that goes. I'm probably putting the cart before the horse on that one because I don't even know that it's going to work. Looks like that pad came loose. Okay. Overall, it did pretty well. I don't have to shield the board anymore because I don't have that hot air running around here. The hot air comes out of that thing at about 400 C and it'll roast anything in the way. You saw it burn the sticker a little bit there. Not optimal. And I just want to make sure that we're going to be nice and clean. I'm going to be using the solder wick a lot for this surface mount. Okay. So, after that's done, take the isopropyl and let's clean what we have here. Alright, so that's clean. Now you can see this little pad right here moved on us. You're going to have to watch that guy. It didn't move much. Okay, so now we have our 486 here. See it right there. Little 486 ready to come out of hiding. To tack this in real quick, I'm just going to dab over here in the corner. This is a ground that incorporates 2 pins, so it's a good spot to get us set up. And all of our pins lined up nearly perfectly. So let's tack a couple more here. So she doesn't try to move on us. I should have a small bit on this thing. I guess I don't really need to worry too much about bridges at the moment, because I'm about to create a whole bunch of them. Alright. Yeah, that's good. Pins are all nice and in place and everything. So what I'm going to do now is I'm going to apply my liquid solder flux, because I want to make sure that I have tons of flux. I can clean it up later. Now, there's a thermal pad underneath that's not going to be attached to anything, but there's not really much I can really do about that at the moment. So it's just going to have to, live with what it's got. Let's get our iron all soldered up, and then we will try the drag method here. Bad angle with the tripod there, but I think I can do it this way. Alright, that actually looks really good. So then we go in with our we go in with our solder wick, and we can clean up the final side here that we ended up on when we did our pull through, and then we've got one side soldered in. Come on, wick. Soak it up. It's a bad angle. This is probably the worst angle with this tripod here. Almost. Just one little bit left. These other two sides should be much easier. And there we go. That should be clean all the way across. Now, I'll just do the same thing on the other legs. So, what we'll do here is, we've already got our flux, so we just charge with a bit of solder there. And then we get down on the pins, and we slowly drag across. And actually that one ended up with almost nothing on the pins. After I was done, there's a little bit on the last one. Wonder if I can get it off with this. Nope. Okay. So let's use our soldering wick. Grab that little bit off of there. There we go. Clean. Now for this other side here, charge up our iron and press and drag. The wick allows you to do this. The solder wick, not the wick, I'm sorry, the flux allows you to do this. It's really good about making sure that the solder doesn't create bridges and just cause a whole bunch of havoc for you. This is my preferred way of soldering a lot of SMT pins. I mean, imagine if I had to sit here and solder every one of these pins individually. Woo. I mean, I would still do it, but now this one, because the two last pins over here are ground, I may be able to get away with just dragging across this and not using the wick at all. Okay, slowly but surely, let's do this. Well, this side isn't dragging as well as the other side was. Nope, I ended up with a couple bridges on this side. Darn. I thought that'd be the easiest one. That's okay. Got that one. Got that one. And typically you have enough surface tension underneath the pads that you can wick away like this and you don't have to worry about any pins being loose or anything like that on the board. So it usually works out pretty well. The flux is the biggest. The flux is the biggest thing. You need the flux. Flux, flux, flux. Can't say it enough with the surface mount soldering. But one thing that we can do, and I'll show you that right now, is we use a little microscope to check every one of these pins. We can do that fairly easily with an electronic microscope that I do have here. So I'm going to show you that. This process of checking the pins is fairly straightforward. You just take a pointed object, I use a small pick that I have, and just run it along the pins. The pins that aren't soldered in should move a little bit when you go across them here. I wasn't able to get this last pin because of the little nub that's on the processor. So went back and over it, and as you can see here, the pin does move a little bit. To remedy this, especially with just one pin, all you really need to do is just dab it a little bit with the soldering iron, just a little quick touch. Typically, there's enough solder on the joint that it will hold. It just needs heated a little better. And then we can go in with the pick and nudge it a little bit, see if it moves. And if it's firm, it's soldered. That's it. All right, so first things first, I've got the old 386 here for good luck. I've put some RAM in there that I don't care about. This is the smoke test. I'm going to see if this comes on before I sacrifice a good ISA card or something to this thing. So let's hit the power on and see if it fires up. Looks like we have all our voltages and everything, but no, it is not. So we'll have to troubleshoot this guy and see what could be causing a problem. There's a couple of options here. I noticed CP1, CP3. I need to see what those are on this chip. It's possible that I may have to bridge a jumper or two here to get this going. Let me go ahead and see what that pin goes to, and we'll see if we can get this guy working. Okay, I think I may have figured out why this processor isn't working. My theory is that I've blown this processor out. I came to that conclusion based on some internet research. This processor is 5-volt tolerant. That means its I/O is capable of doing all the 5-volt signaling it needs to for this board, but the core is 3.3 volt. And I believe when I connected 5 volts to this core, I may have blown it out. The reason why I think I've blown it out, though, is because all x86 processors start up the same way. ARM might be similar, but x86 processors, when they boot up, when they're reset anyway, they have what's called a reset vector. It's a hard programmed address that the processor knows to go to begin execution of code, to boot up. And that address is always 16 bytes from the end of a BIOS ROM. So it goes to here, reads that 16 bytes, and that instruction tells it where to go. Most BIOSes, it's like, okay, go to my initial address and then start executing, so forth and so on. This processor never goes to address, what is it? It's like 6 Fs and a 0H in hex. It never goes to that address, and therefore never begins executing code. And I have an identical board to this that still has the 386 SX40 on it, and it does go out here and start executing code. This guy does not. So what I've picked up is a battery damaged 486 SLC motherboard off of eBay. It has some pretty bad corrosion and stuff up here. In fact, I think it's even gone between layers potentially, because a couple of pins on this processor are even corroded. So I'll have to clean that up. So what I'm going to do is I'm going to desolder this, I'm going to desolder this, and then I'm going to solder this processor onto this motherboard, and then hopefully we can then fire everything up and do our benchmarks. Yeah, let's see how it goes. All right, so we're preheated here on my board heater, and I don't have this masked off, mostly because I don't plan on really doing much with this board again. I may come in and use the RAM slots or the ISA slots for future projects. I'm going to keep the board, but I am not going to mask off stuff like I normally do. Let's get our heat gun going, and then we are ready to begin desoldering, while attempting not to mess up the label on this guy. That solder's melted. That solder's melted, so is this. And there we go, we're free. Alright. See how hot did we get our chip here? Okay, it looks like 317. That is just about what you expect for surface mount soldering. So here we are. We have our Cyrix chip free with good clean pins. Now I'll swap over to the other board and remove the processor from it. Alright, let's get this guy unsoldered now. A quick detail here. I've gone ahead and masked off this processor. That mostly has to do with the fact that I don't want to melt pieces of this motherboard because I actually care about it. So I'm going to go ahead here. We may get some flux smoke going on this guy. Ooh. Sorry if I end up in the way here. Smoky. Okay, she's starting to wiggle around a little bit. Alright, there we go. Nice, clean removal. Look, none of the pins are even bent. Sweet. Alright, not that it matters, I can't use that thing anyway. So, what I'm going to do here is clean this guy up and solder the Cyrix in place. Let's get this bad boy soldered on there. Okay. Put maybe a little less flux than last time since it made such a huge mess. Usually helps to have a lot of flux, but it's kind of hard to clean out from underneath this chip. Right. We will make sure that pin 1 is actually at pin 1. Alright, finally we're here. The Cyrix chip had some bent pins. They were even bent on the donor board, so when I desoldered it and tried to put it on here and line the pins all up perfectly, they didn't, so I went ahead and painstakingly straightened every pin and got it all soldered, and I ended up doing that off camera because that's annoying to watch. So our Cyrix is soldered in, and here's our moment of truth. Ooh! Yay! Alright, so we have our system loaded here. CMOS memory size miss, that's fine. Run setup utility. Okay, I'm going to set up the hard drive and everything, and we will work on some benchmarks. Awesome.